Okay, this is number 19 on the Chapter 4 exam review. This is an application problem for quadratics. We are going to solve the problem where we have a function that is giving us a path of a rocket launched, and we need to answer questions based on the equation. So using the equation or function h of t equals negative 4.9 t squared plus 39.2 t plus 2, it says h is your height of the toy rocket after t seconds. So our t in this problem is representing our x variable, which is time, and our h is representing our height, which is our y. So that's going to be important to know. So when we find our vertex, the h is representing our time, and our k is actually representing our height in this problem. So this is actually hk when we're looking for our vertex. Now, anytime you see in your problem maximum or minimum, that is talking about the vertex of a parabola. The shape of a parabola is a U, either upside down or right side up. If it's upside down, the vertex is your maximum point, and if your parabola is right side up, your vertex is going to be your minimum. So this will be your max point, and this will be your minimum point. Okay, so when we're looking for a maximum, we're looking for this point right here, which is called hk, which we know is the vertex. So there's a couple ways to do this. We can find a vertex by using the equation opposite of b over 2a, or putting this equation in vertex form. I will do both for you. So we can start by putting this equation in vertex form by grouping together the negative 4.9 t squared plus 39.2 t terms, and then keeping out your plus 2. Now we want to factor out the negative 4.9 out of both of these terms, not just the t squared term, but both terms. When you divide out a negative 4.9 from 39.2, you're going to get a negative 8t plus 2. Okay, so now we're going to complete the square. So we're going to take half of negative 8 and square it. So 4 squared is 16, so we're going to add 16. Now if we add 16 to this side, we have to put it on the other side to make sure that our function stays balanced. But this isn't really 16. This is really 16 times negative 4.9. So 16 times negative 4.9 is 78.4, or negative 78.4, so we're going to put negative 78.4 on this side of the equation. Now we're going to simplify by factoring this expression and moving the negative 78.4 to the other side. So our final vertex form is going to be h of t is equal to negative 4.9 times t minus 4 squared, and then I can add 78.4 over here, and I'm going to get 80.4 for my final equation here. So this is vertex form. Now this gives me my vertex hk. H is always opposite in the with the x. So 4 is your x variable for the vertex, and 80.4 is your vertex for your y. So this, in our case, is t comma h. So this is your time, and this is your height. So now we can answer the question based on maximum, because it asks for the maximum, so we now have our maximum values. So it says, when does the rocket reach its maximum height? When is talking about a time. And it's even telling you t equals. Well, our t was our x variable. Our x variable of our vertex is 4, so our answer is 4 seconds. Now, if you didn't put the equation in vertex form, you would need to get that in a different way. You can do that by using the equation opposite of b over 2a, and then comma, f of opposite of b over 2a, which is just the notation for opposite of b over 2a being your x-coordinate of your vertex, and then substituting in the x-coordinate of your vertex into your function. In this case, it's the h of t function. So we can use opposite of b over 2a to get the time, is what we're asked for in this problem. So we're going to do opposite of b, which is, in our case, 39.2, over 2 times a, which is negative 4.9. Okay, when we solve that, we're going to get 4, and that gives us 4 seconds. Now for the maximum height is our k value of our vertex. So we want to substitute in 4 into our function. So our function is h of t, so we want to solve for h when our time is 4 seconds. So we're going to do h of 4 equals negative 4.9 times 4 squared plus 39.2 times 4 plus 2. And if you put that into your calculator, you'll see that you should get 80.4, and that will be feet. 80.4. But you could have also just looked at your equation up at the top in vertex form, and your maximum height is always going to be your k. Okay, for the last question, when does the rocket hit the ground? Well, this is giving you a value to substitute in. When the rocket hits the ground, it has a specific height that you know is for sure. The height at ground level is h is equal to 0. So what we want to do is just to substitute 0 in for h into our function. So you can do this into either form. You can do it into vertex form, or you can do it into the standard form. I'll do it in standard form first. So we're going to do 0 is equal to negative 4.9 t squared plus 39.2 t plus 2. Okay, when you have a quadratic and you're solving for the x variable, and in our case the t is our x variable, we need to use one of the methods, either factoring, quadratic formula, or completing the square. This looks like it would be easiest for a quadratic formula because we don't have any real nice numbers in here. So let's use quadratic formula. X equals, or in our case t equals, because t is our variable for x, t is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. I'm going to evaluate the discriminant first. b squared minus 4ac, 39.2 squared minus 4 times negative 4.9 times the c, which is 2. So 39.2 squared is 1,536.64. Then I'm going to look at my signs. I see there's 2 negatives. 2 negatives multiplied together gives you a positive. And then I can just multiply 4 times 4.9 times 2. And that's going to be 39.2. So my entire discriminant is 1,536.64 plus 39.2. And that will give me 1,575.84. So we can substitute that into our quadratic formula. Opposite of b is negative 39.2 plus or minus the square root of 1,575.84 divided by 2 times a, which is negative 4.9. And then we can just put that in the calculator. And I'm going to show you the calculator because you'll probably or could possibly make a mistake on the calculation here. So what you want to do here is type in the negative 39.2. Let's do the positive root first. We'll do the plus. Type in the square root of 1,575.84. And at that point, you need to get an answer. Equals. And then you can divide that answer divided by parenthesis 2 times negative 4.9. You must have the parentheses around the denominator because you're multiplying by a quantity. So go ahead and get an answer there, and you get negative 0.05. And then we need to do the value for the negative root, so we can clear that and start over. Let's see, we can put in negative 39.2, and we can do minus the root of 1,575.84. Get an answer, and divide that by 2 times negative 4.9, and get an answer for that, which is 8.05. So when it hits the ground, this is before it's launched, so we don't want that answer. This is after it's launched, because if we would draw a quick sketch, we'd know this rocket would be at the ground a little bit before it was launched, which would be at time 0.05 seconds, negative 0.05 seconds, and it'll hit the ground over here at 8.05. Oops, I'm sorry, you can't see that. Okay, so, and then our maximum height we know is a maximum height. We found that is up here at 80.4 feet, and it took 4 seconds to get there. So that would be a quick sketch of the graph. So the time we want when it hits the ground is 8.05 seconds.